Hi dear children, welcome back all of you to the online physics theory class, Royal Palace PU College, Jamkhandi. Right, so you know that already we started the chapter magnetism and matter. In that the basic concept which are related to the magnet and the magnetism. So we talked in the previous class, right? And also we have seen the different images which are related to the magnetism concept, right? And also we had a discussion over the commonly known ideas about the magnetism, where you came to know the earth behaves as a huge bar magnet, and next the magnetic like poles will repel and the unlike poles will attract, right? And later the magnetic pole strength means that is more at the pole, and which points to the geographic north is called north pole, which points to the south is called the south pole. Then the magnetic monopole does not exist, that also we came to know, right? And you also came to know that the commonly known or the commonly using magnets, what are those? The shape, based on the shape of the magnet we have classified bar magnet, horseshoe magnet, ring magnet, cylindrical magnet, right? So today I am trying to show you that magnets in this video, and later we talk about another 2-3 points related to the magnetism. Then what are the magnetic field lines? The very important concept that may be asked for the 2 marks or 3 marks. Mention the properties of the magnetic field lines and also draw the magnetic field lines for a given bar magnet or solenoid, right? Today's concept is very important concept, right? Yes, firstly I want to show you the bar magnet and the horseshoe magnet. See dear children, I think already in your lower classes you have seen such a magnets, right? So this is a what? The bar magnet, commonly using it is, right? And this is the U-shaped or horseshoe shaped magnet. And here, so these two are the poles, and here also these two are the poles, right? And one will be a north pole, another will be south pole, right? Then now I want to show you how there is a attraction and the repulsion between the related poles. Suppose see here, now these two are repelling each other. Why they are repelling? They are maybe north pole or south pole. So this is showing us that the like poles repel each other. That is the main point. Okay. Then just you change the pole. Now you can see how nicely they are attracting. So this shows us that the unlike poles, that means one is a north and another one is a south, that will attract each other. Okay. So this is a main, that's why I told you last class, the attraction and the direction or the directive property are the important property of the magnet. Okay. Then one more thing, when we used one term that a freely suspended bar magnet or normally a magnet can give us that always stands or that always points to the north-south direction. So I am going to try to show you that. See here, this is a what? The freely suspended bar magnet, right? When it stands, that is showing us the north-south direction. Due to the wind or the air, little deflection will be there, but so when it stands, that shows us the north-south direction. Okay. Then another one magnetic, so material is there, that is magnetic compass. See dear children, this is a what? The magnetic compass. Okay. So that shows us the, and earlier days these used to find the direction in the navigation, right? To find the direction, that people used to used this to find the direction. Okay. And this is a what? The magnetic compass, that is also showing us the north, how you will move, and that will show us the direction. And one more very important thing of this using the magnetic compass is that with the help of this we can plot the magnetic field lines around a given magnet. See dear children, this will help us to trace the magnetic field lines around a given magnet. Okay? I hope you understood the points whatever I talked now. Right. Coming to the next point, the commonly known ideas, where one more point is very important, that is the repulsion. See, the attraction. Already we know that magnet can attract any iron material or the alloys of the iron material or piece of any iron material. But repulsion is the surest, that is a test for finding that is the magnet. Sure test is that repulsion. Why? Because only the magnet if they have the like poles, they can repel each other. So keep in your mind, which is a sure test to find the magnet means repulsion or repulsive property is the sure test to find the magnet. Okay. Then next one, the Coulomb's law in the magnetism. See dear children, already you know about the Coulomb's law in the electrostatics. That is, whenever 2 point charges are separated by a short distance, the force of attraction or the repulsion, that depends directly on the product of magnitude of the charges inversely on the square of the distance between them. Similarly, if I take, this is a bar magnet or any one magnet, okay, and I mention here one pole or one point of that is the north, another point is the south. And remember dear children, the pole strength means the maximum field is present at the pole of every point, every magnet. This point should be noted, right? Means at these poles only they have the maximum strength of the magnetic field, right? Then if so, m is represented, small m if I take, this is the pole strength of the north pole. I mention it as the m1, and m2 is taken as pole strength of the south pole, and both the poles are separated by a small distance. Then the Coulomb's law in the magnetism can be given as the force of attraction or repulsion between the two poles is directly proportional to the magnitude of the, or else directly you can say the product of the pole strength of the magnet, right? And this is that same one, the force of attraction or repulsion is inversely proportional to the square of the distance between them. Then these together I can write here, the Coulomb's law in the magnetism is given as mu naught upon 4 pi into m1 m2 upon r square. This is my formula. Yes, where what is the F? F is the force of attraction or repulsion between the poles, and next mu naught. Remember, already you know about the epsilon naught. What is epsilon naught? That is the permittivity of the free space. That permittivity means what? How much, what is the strength of the that free space to allow the electric field lines. Similarly here also mu naught is called permeability. It is called permeability of free space. Free space. That means what is the strength of the free space to allow the magnetic field lines to pass through it. That is a permeability, ability of the field lines to cross through that free space, right? And r means the distance between the two poles, and m1, m2, as you know, this is the pole strength. Is that clear? Yes. Then let us move to the very important concept, that is magnetic field and the properties of the magnetic field lines. See dear children, every year either midterm or preparatory or the annual, one question may come on this. Mention or write the properties of the magnetic field lines. Okay? And that we have to know, and after that let us talk what the difference you are finding between the electric field lines and the magnetic field lines. Okay? Then firstly we talk about magnetic field. Magnetic field. Yes, what is the magnetic field? Electric field means you can answer this is a space around the electric charge where the charge experiences the force. Then what about the magnetic field? Same only. This is also a space. This is also an area around a magnet at which the magnet, another magnet can experience the force. Such a space, such an area is called as the magnetic field. For example, if I take this is the magnet, around this magnet there is some area, right? At this area, if I bring any other magnet, means definitely it experiences the force. Such an area or that space around the magnet where the another magnet can experience the force, we call as a magnetic field. Is that clear? Yes. And moving to the next one, the magnetic field lines. Field lines. Yes, this is an important point. What are magnetic field lines? The lines around a given magnet through which unit north pole can move. That means, so again I can draw here a magnet, yes, call it is a north and this is a south. Field lines means these are imaginary lines. Remember, if you see, just now I shown you the bar magnet. If you ask me, show madam where are the lines, means I can't show you. But with the help of iron fillings and this bar magnet, if I do a small experiments, if I pour the iron fillings on this and tap the card sheet or something where I kept the magnet, definitely I can show you how the magnetic fields are present around the given magnet. Okay? So, but these are imaginary, we can't see them, but we can experience its forces. Okay? So, therefore, magnetic field lines means these are imaginary line or the line around the given magnet through which unit north pole can move. Okay? Then what are the properties of the magnetic field lines? Very important for either 2 or the 3 marks. Important concept, that is properties. Properties of magnetic field lines. Field lines. The first property is that magnetic field lines are the closed loops around a given magnet. Remember children, this is the most important property of the magnetic field line. What are magnetic first property is that the magnetic field lines are the closed loops around a given magnet. Okay? These form, or you can say these form closed loops. Closed loops. Second main property is that, two magnetic field lines will never intersect each other. This is another most important, or the, so already the same point you talked in the electric field lines also, right? The second property is that two magnetic field lines will never intersect each other. Then my question, if they intersect, what will be the result? What happens? See, I can show here, this is the one magnetic field line, this is the another magnetic field line. Assume they have intersected each other at a common point. Then observe this intersection point. What is there? You are getting two magnetic direction here, two direction. Here also one direction, here also one direction is there. Then is it possible to get two direction for a single magnetic field experimentally? No, never. So that is why two magnetic field lines will never intersect each other, they never intersect. Because the reason also they may ask why? Because for a single magnetic field, two direction at a given point is impossible experimentally. Am I clear? Okay. So then moving to the next point. The second property is that no two magnetic field lines intersect each other. Right? Next one is how to represent the direction of the magnetic field by the field lines. Very simple. I want to draw again here the magnetic field lines. This question also once asked in your preparatory. Draw the magnetic field lines around a given bar magnet. Remember dear children, magnetic field line around a bar magnet. Yes, draw magnetic field lines around a bar magnet or solenoid, both will be same, but for the solenoid that will be wounded with the copper wire, that's slight difference. Okay, but remember both behave same, that derivation also there, we talk here later. Coming to the point, this is the bar magnet. Yes, and as you know, north and south. How to draw, how to plot the, so magnetic field around this means that shows and see dear children, in this the direction is very important. See now just like this only drawing means you carry 0 marks here, no mark will be allotted. Then when you can get the marks? You can get the marks when the direction of the magnetic field is mentioned. Remember this. Yes, what observation you are doing here? The magnetic field lines are starting at the north pole and terminating at the south pole outside the bar magnet. This point should be very clear. See, the magnetic field lines are starting at the north pole and terminating at the south pole outside the bar magnet. Then what about inside the bar magnet? That is starting from the south and terminating at the north inside the bar magnet. I am clear? Yes? So, very clear point here. The next point is that the magnetic field lines are starting from the north and terminating at the south pole outside the bar magnet and from south to the north inside the bar magnet. Yes? Then moving to the next point, see for this magnetic field lines? If you draw tangent to any point to the magnetic field, any point. See here, this is forming the closed loop, right? If you want to draw here, here, or if you want to mention this is a point, B point, C point, wherever you want, if you draw the tangent at that point, it gives the direction of magnetic field at that point only. The fourth point is what? The fourth point or the fourth property of magnetic field line is the tangent drawn at a given point to the field line gives the direction of the magnetic field at that point only. Yes? So then next point is about magnetic flux density. Magnetic flux density. What does it mean? See, almost all the points which we are covering now, these all are relevant to the second chapter, electrostatic potential. There also you studied electric flux density, the properties of electric field lines, right? So both are related each other, but slightly difference is also there. Yes, magnetic flux density, what it gives, how to obtain this? Suppose this is, consider this is a one area. Then through this area, how many number of the field lines are crossing per unit time through that unit area perpendicular to its direction gives the magnetic flux density. Remember, what is magnetic flux density? The amount of the magnetic field lines crossing unit area, unit time, kept perpendicular or normal to the direction of the field, that gives the magnetic flux density. Okay? Then the last point is, so just as I told you, if the magnetic field lines are crowded, the strength of the field is stronger. If the magnetic field lines are separated apart, the magnetic field strength is smaller or it is low. Remember, dear children, where the means here you can observe this diagram, you can observe here the more number of the field lines are there. That is why I told at the pole the strength of magnet is more, because the lines are closer, the lines are crowded at the pole, and when you move from there to another pole, they start to depart. Then when they start to depart, by the time the strength of the magnet goes weaker. Yes? So these are the main properties of the magnetic field lines, and also we talked about the bar magnet, right? And remaining points we see in the next class. Okay? So thank you for watching the video.